They were asked to go relook at one of the platform structures from problem 112, but now we're placing the load that was acting at point B um, or point D, or no, with the load that was acting at point B with the couple that's now acting at point D. So we can do that, and what we find is we can go back and look and get all our coordinates we had from problem 112. And now we know we had all these two force members that were supporting the two pin platform members. And instead of having a force at point B, now an external load, we're going to have an external load at a external moment at point D, and I'll just call it, because it's counterclockwise, so it's clockwise, so it's going to be negative with a magnitude of m naught. So we can again do our sum of forces and moments, and again I did it on each of the two upper platforms, which basically I could have either done it on the entire structure and then one of the platforms, or each individual platform would get the same answer. The entire structure would be just if you took all of the equations that we got here and add them together. Not all of them, but all the forces in the x direction, add that to the forces in the x direction from this set, and the forces in the y from this set to this set, and the moments from this set to this set. And you can just check that for yourself, that we get the equations that we would have gotten if we just used the entire structure to model. So we have now we have an external moment here. So the external moment's acting at all the other points, A, B, C, and E are 0. And again, we got to remember to keep one of these internal forces has to have a minus sign in front of it, so that when we add the equations up, they would cancel out. And so we get we have again we have 6 unknowns. The forces in the two force members, and then the two forces at the pin joint, but we're not asked to figure out what those are. And so we're at the forces in the two force members. The first one is 1/4 m naught over A, and then in B we have 1 over square root of 2 m naught over A. At D we have the same, and at E we have minus 3/4 m naught over A. So it's a little hard to think about, but if we put a couple at point D on that structure, it makes sense that this would be in compression, and these would be in tension, and this would also be in compression. That seems to make sense. Obviously, we have the right units. Now A shows up into our answers. So if A were kilometers and this was kilonewton meters, then we would have a Newton meter kind of thing here. Or this could be millimeters, and this would be Newton millimeters, something. So again, we just have a scaling that goes like m naught over A for our forces.